Okay, 5.2, more on exponents, zero exponent, and negative exponents. So when we have like basis, we've learned that we subtract the exponents going from the top down. So in this case, it would be 6 to the 2 minus 5, or 6 to the negative 3. Now, we don't want any negatives in our exponents in our answers. So 6 is the same as 6 over 1. So in order to move this, make this positive, we move the negative portion to the bottom, or in other words, put it into the denominator, and the 1 to the numerator. So we just switch places, and the negative 3 becomes a positive 3. Likewise, if we had 6 squared, 6 times 6, divided by 6 times 6 times 6 times 6 times 6, or 6 to the 5th, we would see that if we cancel this 6 with this 6, and this one with this, they would become 1s. So 1 times 1 would be 1, and we would have 3 6s multiplied together, or 6 to the 3rd. So the same situation applies. You just have to change the position of the negative. So the generic rule is that x to the negative n power, that's x over 1, is equal to 1 over x to the positive power of n. So when we have a negative exponent, we have to change its position to make it positive. Same what goes with numbers. So if we have 5 to the negative 2 power, that's 5 over 1, minus 1 over 10 squared, we change the negative 2's position to make it a positive. So we have 1 over 5 squared minus 1 over 10 squared. This would be 1 over 5 times 5, 1 over 25, minus 1 over 10 squared, which would be 1 over 100. Remember, when we add or subtract fractions, we have to have a common denominator. So the common denominator between 25 and 100 is 100. So changing the 1/25 to hundreds, we would take the 25 into 100, goes 4 times. 4 times one of them is 4. 100 into 100 once. 1 times 1 is 1, and we're subtracting. So 4 minus 1, our answer would be 3 hundredths, or 3 over 100. Now, one thing you have to be careful of is 9m to the negative 3. This is the only part that's negative. The 9 is not raised to a negative power here, so it stays in the same position. But the m is negative 3, so that has to move in the opposite location. So it's not 1 over 9m to the 3rd. It's 9 over m to the 3rd. Likewise, if we have a negative 5, working with just a number, to the negative 2 power, this has to change position. Keep in mind that the sign of the number does not change, just the sign of the exponent. So we have 1 over negative 5 squared. Remember, you apply the negative last. So this is like a negative 1 times 5 times 5, negative 1 over 25. Now we get to the zero exponent. Anything to the 0 power is 1. So if we had 3 to the 0 power, it would be 1. If we had 4 to the 0 power, it would be 1. Let's take a look at that for a second. If we have x divided by x, each of those x's is to the first power. If we cancel them, we would get 1. If we used our subtraction rule, subtracting from the top down, 1 minus 1, we'd get x to the 0, and we just said that that is 1. So it's just a little faster way other than canceling them out. You have to be careful of, if you have a coefficient, in other words, a number in front of the variable to the 0 power, these are separated. The 2 is not involved with a to the 0. So a to the 0 becomes 1, but it's 2 times 1. So the answer is 2. So don't make the mistake of going like this. Oh, that whole thing is 1. It is not. Okay, changing negative exponents to positive. So anything that has a negative exponent, we learned has to change position. So in this case, both of these would change. The b's would come on the numerator and the a's would become the denominator. So again, the generic is, you have a negative exponent, it changes position, becomes a positive. So if we work with numbers again, same rule applies. 2 to the negative third has to change position. 4 to the negative 4 has to change position. And I know on Alex, and it was the same on WebAssign, you need to finish this off. So 3 to the 4th means there's 4 3's multiplied together, which in this case would be 81. 2 to the 3rd means there's 3 2's multiplied together, or 8. Okay, this next one is a good one also, because you see this negative is the sign of the number. It's not an exponent. It's not up here. So the negative 6 stays right where it was. The s squared goes down, changes position because it's negative, and the t's change position. So be careful, because the negative sign is negative, don't move that down. A little bit different situation here where we have a fraction and we have a negative exponent. So in this case, we invert the fraction and the exponent becomes positive. So we change the position of the a and the 2. Instead of a divided by 2, it's 2 divided by a. So when we do this, that means that the 2 is to the 3rd power, and the 3 is to the 3rd power. So this part we have to finish off. 2 times 2 times 2 would be 8. Don't forget, when you have numbers that are raised to powers, you need to finish that. Okay, products meaning multiplication, quotient meaning division. So when we have a combination, let's look at that. A to the 5th times a to the negative 3rd. One way to do it is to say we got a negative here, so that has to go change position. Now we're dividing, we can subtract 5 minus the 3 is x squared. Or, since we're multiplying, you could say, well, that's 5 plus a negative 3, and you get 2. Either way will work. This one, we don't have any negatives, so we have to subtract exponents working from the top down. So 3 minus 7 x to the negative fourth. Got a negative exponent in our answer, so we have to change this position, 1 over x to the fourth. Okay, in the next one, applying our power rule, negative 2 times positive 3 is x to the negative 6. Again, we have a negative exponent in our answer, so it has to change position. Okay, now we have a parentheses with some positive and negative exponents in it. So we always want to clean this parentheses up first so it follows our order of operations. So the 2a to the third is fine where it is, but this b to the negative 5 has got to change position. Now we can apply the power rule.